Hello friends, in this video I am going to teach you about what is scattering matrix. This scattering matrix is very important thing in microwave junctions. We know microwave junctions is used to split or add the microwave signals in microwave waveguides. Okay, what about scattering matrix is nothing but scattering matrix is the matrix which gives the power relationships of different ports of the microwave junction. We know every microwave junction is having two or three or four ports. Two or three or four ports. Okay, and we need to find in sometimes we need to find the power relations between the input ports and output ports. If we incident a power of 10 watts at port 1, then sometimes we need to find how much power is delivered at the port 2 and how much power is attenuated in between the port 1 and port 2. And for finding these power relationships, we need to find the scattering matrix of a waveguide junction. Okay, now let's see first point. It is a square matrix which gives all combinations of power relationships between the various input and output ports of a microwave junction. Already told you it is a square matrix. Okay, that is nothing but 3 into 3 matrix or 2 into 2 matrix, 4 into 4 matrix like that. And it is a square matrix which gives all combinations of power relationship between the various input and output ports of the microwave junction. It gives all the power relationship between the various input ports and output ports of the microwave junction. And the next point is the element of this matrix are called scattering coefficients or scattering parameters. We know every matrix is having the some elements, and each element in a scattering matrix is known as scattering coefficient or scattering parameter. Now, it is the mathematical representation of how microwave energy propagating in multi-port network. Now let's see mathematical representation. Let's see it is a two-port network like a general waveguide. A general waveguide is having the two ports. Now I'm going to find the power relationship between these two ports. Let's consider it is a input port and it is the output port. Let's consider it is one port, like you can also consider it's the first port and it is the second port. Now the power incident at first port is A1. Here observe the power which is incident at first port is A1 and the power which is incident at second port is A2. Now here B1 B2 is nothing but we know in practical case there is no perfect impedance between the but there is no perfect impedance matching between the port 1 and port 2. Okay, ideally there is impedance matching, but practically there is no perfect impedance matching between the any ports of the microwave junction. Okay, due to that there is some reflecting power occurs. If we incident a power A1 at port 1 due to impedance does not matching, some amount of A1 is going to reflect back again. Okay, and some amount of A1 is going to pass to power port 2. Likewise, if we incident a power A2 at port 2, then some amount of power is going to reflect back again to the port 2 due to the impedance mismatching, and some amount of power is going to pass to the port 1. Okay, and that reflected power is known as B1. Here B1 is nothing but reflected power plus the power which is coming from the another port. If suppose this port 2 is passing the power of A2 to the port 1 and some amount of power is reflected back to the B2, like B2, and some amount of power is going to pass to the port 1 as B1. Okay, as B1. This B1 is nothing but the power comes from port 2 as well as the power which is reflected at port 1, and this B2 is nothing but the power comes from A1 and also the power which is reflected at the port 2. And this is about the two port network and their power relationships. So now let's see how this scattering matrix appears, and it is the scattering matrix of the two port network. Here B1 B2 are nothing but the scattering parameters, not a scattering parameters, reflected parameters. Here B1 B2 are the reflected parameters. Here S11 S12 S21 S22 matrix is nothing but a scattering matrix. We know it is a two port network having two ports. One is input port and another one is output port. There are two ports is nothing but the matrix is 2 into 2 matrix. Here observe, it is a 2 into 2 matrix. If we consider the microwave junction as a 3-port junction, then the matrix will be like this 3 into 3 matrix. If our microwave junction is having the 4 ports, then the matrix is having 4 into 4 matrix. Okay, then a1 a2 is nothing but the incident powers, and it is the scattering matrix of the two port network. This relation you remember, every time the scattering matrix is nothing but reflected powers. Here b1 b2 is nothing but powers. Reflected powers is equal to the scattering matrix into transmitted powers. Here the scattering matrix parameters represents the impedance matching. Okay, here the scattering matrix parameters represents the impedance matching. Impedance matching into incident power. Okay, reflected power is equal to impedance matching into incident power. Here b1 b2 is the reflected powers, S11, S12, S21, S22 are nothing but the impedance matching parameters, which is used to represent the how much impedance is matching from port 1 to port 2 or port 2 to port 1. And A1, A2 are nothing but the transmitted power or incident power, and it is the relation between the scattering matrix, reflected powers and incident power. Remember this. Now from this expression we can expand this expression like this, that is a b1 is equal to s11 a1 plus s12 a2. Here observe, b1 is equal to s11 a1 plus s12 a2, and keep it as a equation number 1. Now b2 is equal to s21 a1 plus s22 a2. Here observe, b2 is equal to s21 a1 plus s22 a2, and keep it as a equation number 2. Now observe, there are scattering parameters s11, s12, s21, s22. These are the scattering parameters. It's like sij. We know where what is sij, where I is nothing but output port and j is nothing but input port. Here observe, it is in the form of S1, Sij. All the scattering parameters are in the form of Sij. Here I is nothing but output port and j is nothing but input port. Here let's consider a scattering parameter like S12. Okay, S12. Here this one is nothing but output port and this 2 is nothing but input port, which is nothing but when the power is incident at port 2, then how much power is delivered at port 1. Okay, S12 is nothing but 1 is the output port, 2 is the input port. Input port is nothing but power incident port. Output port is nothing but power delivered port. This S12 expression represents when the power is incident at port 2, how much power is delivered at port 1. Like when we consider, for example, when we consider S11. S11 is nothing but when the power, here the first one represents the output port. The first one represents the output port and second one represents the input port, which means when the power incident at the port 1, then how much power is reflected again to the port 1. Okay, then this is about the S11, S12, S21, S22, the parameters of scattering matrix. Now let's see, if port 1 makes perfect impedance match, so there is no reflections. For that, A2 equal to 0. Substitute A2 equal to 0 in equation 1 and 2. We know if the port 1 is perfectly matched condition, under perfect matched condition, we know A2 equal to 0, because A2 is nothing but the power which is incident and port 2. When the port 1 is perfectly matched, then under perfectly matched condition, A2 will become 0. Now substitute A2 equal to 0 in the previous expressions. In this previous equation 1 and 2, then we will get S11 equal to B1 by A1 and S21 equal to B2 by A1. Now if we consider and interchange the output port 2 to port 1, then A1 equal to 0. Now it means when port 2 is under perfectly matched condition, then A1 equal to 0. When the port 1 is a perfectly matched condition, A2 equal to 0, and when the port 2 is perfectly matched condition, A1 equal to 0 and no reflected signal, and substitute A1 A2 in equation number 1, then we can get these equations like S12 is equal to B1 by A2, S22 is equal to B2 by A2. Now this is about the scattering matrix and the scattering parameters. Now I am going to explain the scattering matrix properties. Okay, this properties of scattering matrix is also known as S matrix, is very important in all the exams. Okay, even sem exam also it is a sure question which will come. Okay, now let's see what is the first property of the scattering matrix. S matrix is always a square matrix of order m into n. I already told you the scattering matrix is always a square matrix. Always a square matrix, nothing but it is having the, if suppose it is a 2 into 2 matrix having 2 rows and 2 columns, 3 into 3 matrix, 3 rows 3 columns, like that. How this, it's based on number of ports. If the ports of the microwave junction is 3, then it's a 3 into 3 matrix. Then this, and if the ports of the microwave junction is 4 ports, then the scattering matrix of the that junction is 4 into 4 matrix, like that. Now next property is S is always a symmetric matrix, that is Sij equal to Sji. If we consider the scattering matrix, suppose example I took, okay, it is a scattering matrix of two port junction. Here observe S11 and S22. S11 and S22 are the, if it is a perfectly matched condition, or in perfectly matched condition S11 equal to 0. How means S11 is nothing but the power which is incident at port 1 and reflected again to the port 1. Under perfectly matched condition there is no reflection power. So S11 equal to 0 and S22 also equal to 0 under perfectly matched condition. Why? Because means when the power incident at port 2 and there is no reflection power again at the port 2 due to the perfect impedance matching. Due to the perfect impedance matching there is no reflection power. So in that case S11 equal to S22 equal to 0. And one more property is, I already told you, S matrix is always symmetric matrix. Symmetric matrix is nothing but S12 equal to S21, like this. S31 equal to S13, which means Sij equal to Sji property. It is nothing but symmetric. Here observe, it is S12 and it is S21. These two values are same according to the properties of the scattering matrix. Let's see the properties. Okay, according to the symmetric property of the matrix, Sij equal to Sji. Now coming to the third one, that is S is a unitary matrix. S matrix is a unitary matrix, that is S into S conjugate is equal to identity matrix. Unitary matrix is nothing but if we multiply the S matrix with its conjugate, then we will get the identity matrix. Okay, it is nothing but unitary matrix. When we call the S matrix as unitary, whenever we multiply the S matrix with its conjugate, then it will results identity matrix. Then we call that S matrix as a unitary matrix. And the fourth one is, let's observe, all diagonal elements of S matrix equal to 0 under perfect matched condition. For two-port network, S11 equal to S22 equal to 0. I already told you, under perfectly matched condition, there is no power reflection back again to the same port. When we incident the power at the one port, then there is no power reflection back to the same port due to the perfectly matched condition. Then what will become means, in under perfectly matched condition there is no reflection occurs. That means S11 equal to 0, S22 equal to 0, S33 equal to 0, S04 equal to 0. When S11 is nothing but the power incident at first port and also power which is reflected back at the same port. S22 is nothing but when the power incident at port 2 and then how much power is reflected again back to the port 2. S33 also same wise. When under perfectly matched condition, we know there is no reflection occurs. That means S11 equal to S22 equal to S33 equal to S44 equal to 0. And when we consider the 2 by 2 matrix, I mean 2 port network, then we have only two coefficients. Those are S11, S22 equal to 0. Consider the last parameter, that is the sum of products of each term of any row or column multiply by its complex conjugate of corresponding term of any other column or row is 0. If we consider the two matrix, first matrix is S matrix and second matrix is conjugate of S matrix, then if we multiply or not a multiply, then if you will do the sum of products of any row with the corresponding row of the conjugate matrix, then it will result 0. It is the final property of the S matrix, and these five are the properties of the S matrix. It is very important in the examination while it will ask about the S matrix and S matrix properties. I hope you understood this video. Thank you for watching this video.